Here are the answers to Chapter 9, Section 1, Homework 1. Check them out. Notice in problems 5 and 6, you could just choose an angle or point. And so I chose one angle or one point, but you could have chosen a different one. All right, let's go through them. This first set of problems is really just asking you, do you know what a rigid motion is? A rigid motion means that the two figures have the same size and the same shape. If the size or shape changes, it's not a rigid motion. So I say this one is a rigid motion because I believe this and this have the same size and shape. It just flipped over or rotated. Obviously, this one is bigger and this one is smaller. So no, not the same size. So it's not a rigid motion. This is what we call a rigid motion, and this one is what we call a rigid motion because both of them have the same size and shape. All right, in this next set of problems, we are supposed to, let's see, part A says use arrow notation, and I'm supposed to choose an angle or point, all right, for the pre-image and name its image. All right, so I chose point A, and arrow notation just means I want to show that A maps onto A prime. Arrow notation just shows what the pre-image maps onto. It maps onto, well, obviously, A prime. And then part B, I'm supposed to again use arrow notation and list all pairs of corresponding sides. So, my sides of my pre-image are AB, AC, and BC. Now this one is easy because it used prime notation, so obviously side AB maps onto A prime B prime, and that's how you would show that using arrow notation. Side AC maps onto A prime C prime, and last up, side BC maps onto B prime, C prime. The second one here, number 6, though, is a little bit tougher. You know, the first thing we need to decide maybe is the four corners here, how do they map onto the four corners there? You know, did this shape here, did it rotate? If it rotated, then W would end up here, and W and J would go together. Or maybe it didn't rotate, maybe it just flips. And if it just flips, then W ends up over here and X ends up here. So the question is this a flip or a rotate? And it's hard to tell from the shape, and the reason it's hard to tell is because these two sides both seem to match these two sides. So you can't really tell if it's a rotate or a flip. And I am going to say it is just a flip. So I'm going to say that X matches up here, and W matches up here, and V matches up here, and U here. But you would not be wrong if you said instead this thing rotates, meaning W matches up here, and X matches up here, and U matches up here, and V matches up here. Again, it depends on whether you decide this is a flip or a rotate. I'm going to go with the flip, which is the blue letters. So, all right, so that means X and J map onto each other, and I would say X maps onto J. And when I list all of the sides of my original shape are XU is going to map onto something, UV is going to map onto something, VW is going to map onto something, and WX. And I'm just going to go around the shape here, and maybe I'll do it in red. So I start with XU, and XU is going to map onto this side. If this thing is just a flip, and so XU is going to map onto JM. And then UV is obviously going to map onto ML. And VW is going to map onto LK. And last, WX is going to map onto KJ. And there we go, arrow notation. Okay, number 7 wants to know if I know how to do a translation using a vector. The vector here is telling me that I need to go left 1 and up 4. So I'm going to take each corner and go left 1, up 4. There's A prime. C would be 1, 1, 2, 3, 4. And B would be 1, 1, 2, 3, 4. And I will reconnect them. And now I have taken the whole triangle and gone left 1 and up 4. This one is telling me to go right 3 and up 3. That vector. So right 3, up 3. 1, 2, 3, 1, 2, 3. There's M prime. 1, 2, 3, 1, 2, 3. N prime. 1, 2, 3, 1, 2, 3. P prime, and 1, 2, 3, 1, 2, 3, O prime, reconnect them, and you have translated the parallelogram. Number 9 is asking me to write the rule. Okay, so to write the rule, I just need to take one point like A and see what do I need to do to move it so it ends up at A prime. And it looks like A needs to go this way, 1, 2, 3 boxes, and down 1, 2, 3, 4 boxes. So this is going to be a translation, and the vector is going to be 3 to the left, that'd be -3 in the X direction, and -4 in the Y direction. So I have a translation, a vector, and the triangle. It's not a triangle, it's ABCD. In this one, I'm still going to have a translation, and I need to write the vector. So I pick one point like U and see what I need to do to get it to be at U prime. So it looks like I'm going to go this way, 1, 2, 3, 4 boxes, and I'm going to go down 1, 2, 3 boxes. So the vector would be 4 to the right, down 3. And the shape I am moving is UVWXY. UVWXY. There we go. All right, number 11 is like a real-life translation. It says, you are visiting Washington, D.C. from the American History Museum. You walk 5 blocks east. So when I see that, what I usually do is I pick a starting point, and as far as a map goes, this would be north, this would be east, this would be south, and this would be west. So I have walked 5 blocks east. Then I go 1 block south. So now I've gone 1 block south to the Air and Space Museum. Uh-oh, from the American History. So here I was at the American History, and yeah, now I'm at the Air and Space. Then you walk 8 blocks west, so 8 blocks this way, 5, there's 8 blocks that way, to the Washington Monument. All right, that was 8 blocks west. Where is the Washington Monument in relation to the American history? So, how do I get from the American history to the Washington Monument? Well, it looks like I would need to go here and down. This would be 3 blocks, and this would be 1 block. I'm supposed to describe using directions and using a translation vector. So it looks like I'm going 3 blocks west, 1 block south, right? Because I had to, let's see, this was 5 blocks here, so 3 more is what makes the 8, and then of course the 1 matches the 1. So 3 west and 1 south, or as a vector, that would be 3 to the left, down 1. And there's my vector. All right. Okay, in number 12, you were given a translation of a 4-sided object, PQRS. And it moved it here, all right? So this vector, 10 right and up 15, might look something like this. We had some shape, wherever it was, let's say it was right here, and we went 10 spots right, and then we went up 15, and we ended up here. And we want to know what translation rule would map back? What would take this thing back to that? What would take this thing back to where it started? So you'd have to go back 10 spots and down 15 spots, or 10 to the left and down 15. So that would be 10 to the left, down 15 of P prime, Q prime, R prime, S prime, and that would equal back where you started at PQRS. Notice that this is just the opposite of the numbers that we started with, right? Instead of going right 10, I had to go back left 10. Instead of going up 15, I had to go down 15. All right, number 13. Okay, so the important thing about 15 is right here and here. The important thing is that the vector 2, 3, the ordered pair 2, 3, that was x, ended up at 4, 7. So that means the x value of the ordered pair went up 2, and the y value of the ordered pair went up 4. That means I have a vector of up 2, up 4. That would be my translation vector. And then I can use those same things, I can use this same vector on y, and so the 1 would become a 3 if I made it 2 larger, and the 4 would become an 8, and I would have 3, 8. And I would do the same thing for z. The 8 needs to go up 2, so it would become 10. And the 9 needs to go up 4, so it would become 13. Right? The key is figuring out this vector to start. Number 14. Use the graph at the right, write 3 different translation rules. Okay. So I'm going to start with R, and then I'll do S, and then I'll do T. What translation vector would take R to the origin? Well, it looks like it'd be 1 to the left, down 3. So 1 to the left, down 3, and that's my vector. Okay. Next up, we will do S. To get S over here to the origin, slide the triangle so that S ends up at the origin. You would go 1, 2, 3, 4, 5 left and down 1. So 5 left would be -5 in the X direction, -1 in the Y direction, and that one's done. And last up, if I wanted to slide this triangle so that T ends up at the origin, I would have to go 2 to the left, and then I would have to go up 2. And that's my vector that would send T to the origin. Graph it under the vector again. Okay. So the key to these is knowing what this vector is telling you to do. It's telling you to go left 3 and up 4. So I'm going to start by going left 3 and up 4. And this is where D prime will end up. And then I'm going to take point E and go left 3 and up 4. And here's where E prime would end up. And left 3, up 4. This is where F prime would end up. Reconnect them. And you're done with that one. Here I need to go, let's see, this vector is telling me to go left 5, up 1. So I'm going to go 1, 2, 3, 4, 5, up 1, and this will be K prime. And I'm just going to simply do that for every point. 1, 2, 3, 4, 5, 1. 1, 2, 3, 4, 5, 1. And for M, 1, 2, 3, 4, 5, 1. Reconnect them, and you're done with that one. And last up, the composition. Composition just means you add the vectors together. So if I add these vectors together, -3, 7, and 11, 6, then I end up with 8, 13. And this would be a translation of 8, 13. All right, hope that helps.